shouldn't have worked on it. So the like the word, don't put all of the eggs in one basket. You put things separately. The then even if one fails, some of the partial services would be available. Load balancing, as Pavan said, yeah. And the watchdog timers, this is the when something fails, it's a place or way to go back to last working version. Um, Also, the checkpoint, it is something similar to checkpoint. Integrity check is not necessarily for performance, but even if it's available, even if the content is it's stored, if it has an error, it can be read properly. So integrity check is a part of the availability strategy as well. Canary is a kind of deployment strategy when you have some big software to deploy, rather than tada showing it to the world, to everyone at the same time. You incrementally deploy it. You incrementally deploy it to, say, West Coast, East Coast region, to some group of people, and then gradually increase the exposure of the deployment. That's a canary strategy. The eventual consistency is we'll talk about it more, especially this is important for the data reliability. If you have a replications, it's important to make those replications to be consistent. But the it's difficult to have the consistency instantly across all of the replicas. So the a little lenient strategy is, even if it may not be consistent right away, eventually it will be consistent. So that's a strategy. Let me excuse me. Okay. So right. Um Okay, so there are a lot of system management techniques to make the system and software data available, and these are the examples. I can give you, for example, in multiple choice, these are these things, and maybe other the techniques. Which of the following can be availability technique? You need to be able to choose that. So this is a practical tip, is that the making applications to do something reasonable when things are not right is better than nothing. Okay, so the yeah, so when making it entirely failed or not showing at all, the service can show this one is not working or something is in progress, and at least giving some response will make the user the happier. And also aggressive load balancing or request dropping is actually is better. So before you hit the 90%, close to 100% utilization, you want to do load balancing, um, and you do the request dropping in advance before the server fails. Uh, then you, because of your the request dropping, you cannot satisfy 100% of users, but still it's better to make 80%, 70% of users satisfied, rather than you try to make everyone happy and system crashes and no one will be able to get the service, right? So these are really practical tips. In fact, this coming from the insider of the Google data center. Okay, feel free to let me know if you have any questions. The next one is something called the CAP theorem. The So CAP is an acronym that stands for consistency, availability, and partition tolerance. This is some theorem, or it's not really theoretical theorem. This is a practical, the conventional wisdom, practical wisdom that in systems, distributed systems, the keeping all three, it's practically impossible, very difficult. So you have to choose only two out of the three. That's what it means. Does it sound similar to some, physical property in physics? Heisenberg uncertainty principle, right? Position and velocity of a particle, you can't know both at the same time with a great accuracy. You have a trade-off. That's the principle in physics, and something similar in distributed system. Um, the consistency is a good thing, availability is a good thing, partition tolerance is a good thing. If you cannot really have all three, it's difficult to have all three at the same time. So you have to have a priority, make a decision, getting only two out of the three. So consistency, availability, the the uh, partition tolerance, right? So that's what the CAP stand for. Questions, comments? So this is a really practical tip when you go to industry and in charge of or working on uh, the uh, IT team and the what is the most important thing for your industry service. That's something you have to think about. So not all three they at the same time, but two at the same time. These are different illustrations. Another data center operationer, or even in life, the useful tip is that you know the principle called KISS, which stands for keep it simple and stupid. The stupid is it doesn't mean really stupid, but uh, making things complicated is not a good good strategy. So all the system architecture, making it simple, uh, avoid single point of failure, and if you don't test it, don't rely on it. These are all practical, the data center operational tips. Anyone wants to offer any other strategies? If you have some other tips to add, feel free to do that. Anyone? In research or academia, often we want the in science side, we want really, theoretical, optimal, best. In engineering side, we want something working, right? Computer science and engineering is really, where science meets engineering. But we want things, performance, availability as good as possible, but still we also meet the trade-off, right? Try to make things simple. In fact, the the internet philosophy is making core simple, making the router very, very simple. Um, and also the Ethernet, the reason that it has prevailed a lot of over a lot of the competitions, it's not because it is the best architecture protocol, the to give a best performance, best reliability. It's actually more of the simple and familiarity. Mm. Scalability is a big thing. How to test the availability, um, the in big systems when you have to run thousands of systems and so many different the type of services that are loosely coupled. That's always a big question. the, the you can talk about a lot of challenges of cloud computing, but at the topmost it would be scalability, and again even testing the availability. It's also a big challenge in cloud scale. So these are thank you, Lavi. Yeah, it was thank you. So yeah, okay. So I was saying that these are uh the overview of the data center, the challenges and issues, and some operational tips, right? So let's do a quiz now in the middle of the class. Let's try that. While I'm getting ready for the quiz, any questions? No questions? Feel free to turn on your video. Um, Access code is this. Okay, so for students in the class, I want you to take the quiz now. Actually, I'm showing the answers. Yeah, so these are the questions. This is an open book, open note quiz. Let me know who was able to start the quiz. Just I want to make sure that it worked. Okay, enough. Thanks. Teresa. Yes. So DC hyphen overview, DC capital overview O capital. That's the access code. Um, we talked about actually pretty much the answers in the beginning, right? SSD is becoming cheaper and dominant in storage systems. SSD is a non-volatile storage. These scheduling algorithms are HDD scheduling. I am telling you. Cap theorem we just talked about, right? The those three: consistency, availability, partition tolerance, and the availability, the table that I have shown you. Answer to the last one. Okay. Um, let's see, what was the question? There's a which of the following is not to do with the system availability, how frequently it fails, how long it fails, how long it takes to repair, duration of uptime, uh, the cost of repair. It's not exactly. Yeah. I could also add a question about the availability techniques, right? Yeah, maybe I'll do that in the next class. Okay, so I think time is up. So let's get it started with virtualization. Hmm. Okay, so if you missed some questions, it's okay. I mean, the quiz is really mostly for kind of attendance and just to get you engaged in class. So it will not impact will be very minimal, and you know that the worst one is dropped. I might actually do two worst ones dropped. Um, hopefully it was fun to you. Okay, so let's now we are moving on to virtualization, server virtualization. Any questions, comments? Can be about the quiz or anything. I do encourage questions at any time, right? So feel free to virtualization. Okay, Cheyenne, go ahead. Oh, okay. So the I thought the question was about the availability technique. Okay. So the my question I had earlier was about the availability, but it's the on the diagram, like how long the events fail and then that there it takes time to repair and then another and then it will go up after a while it will fail. So if you look at the times, the progression of the system up and down, how long it fails, how frequently it fails, how long it takes um, to repair, right? So the formula when we talk about it, MTTF and NPTR, it's really about how long it was down or up, right? So that's the thing. Cheyenne, since you have mentioned, I occasionally they get the question or comments from students. It was not exactly on the slide. Um, the it was a part of discussion, I could say, and also I want you to think. The I mean that's a different level of kind of. I mean, cost to repair is something else, right? Yeah. From the figure, it was really about the duration of failure and up. That's about the availability. Availability when we say 5949, yeah. So it is really about the time of all the down and up now. Oh, okay. You see that? So here's the failure events. The well, this is a failure event, and it was up for a while, and then it fails. It takes some time to repair. This is a downtime, and then it was up and failure. So overall time, how much it was up, um, overall time, that was about availability. Okay. Any further question? Um, the If it's not server virtualization, what other virtualization we are going to talk about in this class? Remember three major resources of cloud, right? Compute, storage, and network. So server virtualization and storage virtualization, network virtualization, those are the techniques we are going to talk about. And the first thing is the server virtualization. We're going to talk about a little bit of history and what it is. Can anyone guess what this picture is about? It's to do with a car engine. Yes. Yeah. I don't know exactly what kind of engine it is. The what is this? Right. Thank you. Wow. Yeah. I haven't actually seen them in person, but this is a picture I got from online. So what I was trying to say is that it's the engine behind cloud computing. What is it? That's virtualization. So what it means is that it's an so virtual is a what's the opposite word of the virtual? Reality? Okay. Yeah. Anyone else?
Physical.
Physical, right. Yeah. So the opposite word is, it doesn't mean fake. But I don't mean that way. But there's something not physical, done in software, in abstraction. That's what it means. And the virtual thing can be in many different sense. But here we are talking about virtualization in terms of machine, and here machine is computer, not other machines. So the virtualization here is that ability to run the OS, operating system, on a single physical system but different OS. So multiple OS they running on a single physical system, and the hardware will be shared among them. So cloud computing, AWS, Azure, these cloud services are enabled uh, by this virtualization. It's not the uh, Each server is dedicated to a user whenever a user wants a virtual machine. Excuse me. Hmm. Excuse me. Okay, the it's about the creating something virtual, not actual. So the opposite word can be actual, physical, real, all right? Um, the so it's a creating something virtual version of something, and here it is not about it can be about the storage or network resources, but we first thing we are concerned about is a server. So in cloud computing context, the virtualization typically it is about the first of unless it's specified, it is about the server virtualization, and we say virtual machine. Um, So it's a machine. Virtual machine, what it means is that it's the um, software implementation of a machine. Machine meaning, computer, the that has the operating system where you can run applications. So software can be the executed on a physical, the underlying hardware machine, but the multiple virtual machines can be executed. So virtualization technique, it's really uh, the words that the opposite of virtual would be actual, physical, real. Um, the something similar to what are the words that are related to virtual? You might say not actual, not real, but it's more of the software, right? So it's done in software. That's what it means. In fact, OS, it is a virtualization system. Um, if you think about the the OS, what it does is that it virtualizes all the hardware resources. So in the single computer OS, what it virtualizes is that all other components, main memory, I/O devices, even network interfaces, all these hardware, different components of computer are virtualized, and also different the processes will be running at the same time with isolation. So the two running program, they don't interfere with each other. So that is really virtualization. Uh, as I said, the two processes, definition of processor is a CPU hardware. Process is a running program, right? Processes, multiple running programs, they are isolated from each other thanks to the OS operating system virtualization. So, for example, when two programs are running, they will access main memory, physical part, but they will not interfere with each other. They will have a virtual the consecutive area, they will use each individual running program will use a consecutive uh, memory area, but only virtually, so that they will not interfere with each other. Those running programs will not write on other programs' memory, things like that. Storage the same way. So it does provide the isolations from each other. So this is a really good virtualization technique, but it's not but this OS is the prior OSs for a single computer, Windows, iOS, right? The Mac iOS, although the even um, Linux machines, they were not really the virtualizing entire machine, right? So they only the virtualize the hardware on a single machine and enable the virtual environment to different applications or different users there. Still, it's all on top of a single operating system. So those hardware management was done by single OS. The different OS has a different ways of doing resource management, and that can have a limitation. And also, softwares are developed on top of a certain OS, and that will have a different security or failure isolation mechanisms. The like Linux and Windows, what are the security um, the mechanisms are done? They have their own ways of doing it. In Linux, there are user, group, and others. In user, there it can different permissions can be RWX. So read, write, execution. Other group can have a read, write, execution, and then others. So there are three hierarchy of doing that. And also in terms of data, um, the file, the attributes. There are certain set of attributes already predetermined by the each individual operating system. So operating system, that's great. It does virtualize the hardware, but have its own way of doing it. And and also translating application program into the hardware, into the assembly language. So whenever a software is written, it will be developed on top of an OS and made as an execution file, binary file, and that will only work on on top of certain operating system. You cannot run a binary file um, made from one OS and run it on the other OS. So exe file on Windows won't work on different program. Mm, The and virtualization here is more it can actually the goes below the operating system level. uh, so the operating system can sit on top of this virtualization layer and provide the more flexibilities. Feel free to ask questions as we go. Okay. So this is the actually evolution of even OS virtualization. The long time ago, um, really the when multiple programs so this is a picture. Um, well, actually, before we talk about picture, the we used to have a special purpose machine that can do only one thing at a time. The one thing, like weaving cloth making machine, uh, or just any the mechanical machine. Think about it. Its purpose is doing one thing, right? Or two things. It's predetermined. But when we say general purpose computer, the machine can be programmed to do various things. So that means a general purpose computer. But still, in the very beginning, it was the only the computer were able to do one thing at a time. There was one CPU, one program, one thing at a time. But over time, the OS has evolved that allows the multi-program time sharing. So for example, in this picture, there are three programs running. The users can feel, oh, there are three programs running at the same time on a single CPU. In fact, at the bottom, what it was doing is a time sharing. So each program will have a certain share of the time slot to run the program, and there can be context switching happening. Uh, so that was still possible in the single CPU, and then later the process uh, the multiprocess was introduced to enable more level of the parallelism. And then also thread was introduced. The Can anyone tell us what's the difference between process and thread? Process. Process is a running program, right? That will have a certain its own set of memory, the instruction storage access, right? Yes. Thank you, Cheyenne. So the within the process, you can have a multi-thread. Typical example would be a web server. Web server would be one program running. You don't have to implement that way, but the common implementation is that whenever a client make a request, a thread will be generated and respond with the client. So thread is a lightweight processes. So I already have written it here. Um, the Do you see the cursor? Yeah. Mhm. The lightweight processes, the between thread and process, uh, they will keep all the global variables. So some parts are being shared among the threads within a process. So that's the different evolution. Now, what we are talking about is a machine level virtualization. So the complete OS, they can be virtualized. How it abstracts the each individual IO hardware um, and support applications. Later, we are going to talk about we can also talk about it briefly now. So, machine virtualization is again, the below the operating system. On top of virtual machine, you can have a different operating systems. Uh, and then there is also another evolution of virtualization is the container virtualization. You might have heard of container. You probably have seen containers in the service option from the public clouds providers. In fact, the containers are the more popular common way of doing the development and so on. Um, but at the moment, we can focus on the entire machine virtualization. The relationship between machine virtualization versus container virtualization would be um, like a process and thread. Entire process virtualization versus lightweight process. Virtual machine is entire machine virtualization, and thread container is a lightweight virtual machine. And that means that some parts are being shared, some parts are isolated. So we use the word server a lot. So in a traditional concept, it means that's what the system admin used to talk about. And that means that refers to a machine, physical machine, that has the hardware, OS, storage, and running specific application. For example, Exchange server, database server, excuse me, files server. So these are the individual applications running on a physical machine. Typically, in a traditional sense, one server machine, tower server, used to run one application, one big application like mail server or database server or file server programs, right? So the people can point, oh, this is the email server, this is the database server. They used to talk about it. That is a traditional physical server. And when a server gets overloaded, then system admin have to have a new server. All these services like email, database, file server, you can see that these are serving a lot of clients, multiple clients, and it can be overloaded. It may needs to, and then one may not be enough. So then uh, the uh, yeah, when it's overloaded, it can experience the the service down, and also hardware failure can happen. So oftentimes multiple servers can be used for one service. Multiple servers for one service, making basically a cluster to do that. That will be helpful for fault tolerancy. Um, the having more than one, of course, that helps for, let me go back. Having more than one, of course, that helps the scalability, but still it's limited if it's just a within one cluster, within one location, within one rack, right? So, um, and also not all applications can run in a cluster environment. So what I'm talking about is that what's the traditional server concept and what are the limitations of the traditional the server concept, and therefore, uh, the virtualize the server, how it can be beneficial. That's the storyline that I'm talking about. So here's the traditional server where each individual server has its own hardware platform that has OS storage and applications. When something is down, app is down. Um, so lots of problems, like the hardware maintenance is expensive, not so scalable, uh, difficult to replicate. If you think about actually compared to the virtualized server replication, it's like a CP, the command line. You just copy that file or copy a machine. Entire machine copy is a one. It's the equivalent to file copy. But in this traditional server, you have to procure hardware, install operating system, and then run it. So the it's very difficult and time taking, expensive to replicate. The and also processors are often underutilized. When one physical server, is running one application, um, maybe the with the advances of CPU, it's not always you know the highly utilized. What we want is that system to be highly utilized, but not too much, and the automatic the balancing. Those are the things what we want. I'm showing a lot of different figures of the similar same concept from different sources. Some of them are from research papers. Some of them are from like VMware or vendors like the uh, the IBM, Cisco, and so on. So virtual server here, the main idea is that multiple not programs, multiple operating systems can run on a single machine. That's a uh, that's a big the the evolution novel concept. Uh, and for each individual machine users, it gives an illusion that this application is running on a certain OS on a real hardware. But in reality, you see that hardware is just single hardware being shared. And then here on a single hardware machine server, you can have a Windows, Linux, and Mac, and running different operating system, different applications. That's possible. Do you see something in between our OS and apps and hardware? That's virtual machine monitor, VMM. So VMM, again, that's a virtual machine monitor. Uh, on top of the hardware, there should be some software to do this, right? Just like the OS, what it does is that the hardware abstraction and virtualization of the hardware and make the applications to access those hardware. That's what the OS does. And now uh, OS can sit on top of this VMM. So VMM, is that a hardware or software? Is it Are you guys with me? VMM, virtual machine monitor. It's a simple question. It's not a hardware, right? Then what is it? software. Thank you, Papa. I know my question too trivial, but still I want to see your responses. So virtual machine monitor is a thin software layer that sits right on top of hardware that enables multiple OSs. Okay. You might say, well, why it's not called the virtual machine OS or uh, software monitor. The word sounds like it's more passive, right? It's not doing something active work. Um, the Actually what it does is more active, right? Really orchestrates the hardware, interact with the multiple OSs, uh, the for them to use the hardware. But the name monitor comes from a legacy reason. When it was first introduced uh, by a paper like from IBM, they use the word monitor, so it's used. Another name for this VMM is hypervisor. Hypervisor is a modern term. VMM is the older term, but we still use that. Where did it go? Okay. So operating system is not the one that detects the hardware, uh, the virtual machine. Intention here is that it's actually the thin software layer. With the virtual machine virtualization, server can be virtualized. The previously it was all one-to-one mapping, one physical machine, one operating system, and for big applications like mail server, database server, even though it was possible, typically single application was running on a single machine. Now, with the virtualization or server virtualization, the mapping between application and the hardware can be arbitrary. It's M to M or M to N, M to N, right? So multiple apps can run on single hardware or um, single application can run on multiple of the hardware. Um, So just like the data center, what it can enable is that the the set of hardware platform uh, can support set of applications. So many server, the hardware, many applications. In some sense, VMM is a thin software layer because so it is kind of OS, right? The But when we say the previous one, this OS, Windows, Linux. It's not like a Windows, Linux, or Mac. Um, it is the it doesn't have a particular way that enabling the application APIs, but it interacts with the OS. So the OSs that sits on top of VMM is called this OS. What is this OS? What is the word in front of this OS? I want you to keep you guys you know the alert. It's guest, right? Uh, so these are called guest OS. What's the opposite word of guest? Can anyone type?
Host.
Host. Yes, right. Yeah. So thank you. Was that Ankita? Yeah, guys.
Yes, Professor.
Thank you. So we'll talk about the host OS and guest OS. But here, this picture, there is no OS involved. No, guys. Here, there is no OS involved, entire OS, so just VMM hypervisor. So these are all guest OS, and this is again just hypervisor. We don't call it host OS, but the guest OS can sit on top of the uh, host OS, and That's an example we'll see later. In fact, if you have a laptop, you have the host OS, and if you run a virtual box for Linux, that will be guest OS. So that's a special kind of OS. It's different from what this picture shows. So maybe next time we can talk about okay, it is about we understand the architecture. Maybe it's good, but we want to also go into detail uh, the the why, what kind of benefit it brings. Okay, so let me stop here for today. Any questions?